Hey guys, thank you all for coming. I'm so happy and shocked the amount of people that have actually come to this bootcamp. It means a whole bunch to me and Mateus here as well. I'm one of the co-founders of Build City. A couple of our other co-founders are here as well. Eva's here. Build City is a network of builders, creators, and change makers that have come together in New York to incubate and support one another. We're big on alternative technologies, alternative ideas, really anything you can think of. Like, this is a place to build it, and we're the place to come and get your things accelerated and funded hopefully one day. So I'm so happy for you guys to be here, and without further ado, we'll have Mateus introduce Venture Miner and start the bootcamp.
The mic. Thanks so much, Arnie. It's great to be here. Thanks to the city for bringing this. So, a bit about myself. I'm Matheus Pagani, the CEO of Venture Miner, and we are hosting the New York AI2Web3 Bootcamp. We have been using Web3 stuff for 4 years now, AI stuff for 2 years now, especially now with generative AI. And we're going to see how those two techs can combine together much more than hype, but actually one can solve the problems of each other. How many of you have heard about Web3, blockchains now? Half the room. Okay, most of you actually. Good. And how many of you are working with AI, not necessarily developing, but using it nowadays, like ChatGPT now? Okay, that's the average I would expect. If you don't, no worries. This is a welcoming bootcamp, even for beginner level. But it's very unlikely that at this point it did not interface with ChatGPT or anything AI related in the last 1 year or so. And for this bootcamp, we're going to have a very hands-on approach. So this is the repository that we're going to follow. And this is the QR code. If you want to scan this, you have access. Maybe you want to throw that for your computer, or you just type this Academy AI2Web3 Bootcamp. That's an open source repository anyone can access. It's not the content of the bootcamp itself is not gated. Actually, Academy, this academy that we're building, is meant to be an open academy that anyone can study for free. What we are charging is basically for the food, but it's almost all covered for the sponsors too. I'm going to present them soon. And the idea of this bootcamp is to get you as fast as possible in 1 week ready to build something with AI and Web3. Maybe get a job, maybe launch your own company, get investment, prototype something out there, start a new startup. Maybe you're going to meet co-founders here or friends for building with AI or with Web3. So in this 1 week bootcamp, I'm going to go through all of this content, lesson 1, 2, 3, 4, and 5, this tab, to introduce you with all of these concepts. First of all, introduction to AI itself, because some of the techniques that you're going to use on decentralized agents, decentralized machine learning, decentralized offering for models, they all require some previous knowledge on generative AI. And it's common for us to use this technology without understanding how it works. When you chat with an LLM, you might think that it's intelligent, right? Like it speaks to you, it summarizes things, it suggests things, it seems like a person. So the first lesson is going to be all about that, reviewing the content of why LLMs are not intelligent de facto and why this is important and how we can handle it with it, how we can do the actual implementations of LLMs, even though if they are not intelligent at all, if they cannot reason. If you have already implemented an AI system like OpenAI or something like this for text-to-text tasks, some of these things here are going to be quite repetitive. But again, this is a bootcamp that should be as welcoming as possible for everyone. And at the end of today's lesson, of this first lesson, I'm going to introduce some nice opportunities that we have for this bootcamp. We have just confirmed more sponsors that I'm going to present soon, and some nice opportunities. Like last week, JobStash reached out for us because they want to hire AI talents and Web3 talents here in New York. So they have all of those job openings globally too, but they want help here in New York. So this link is very good for you to check later, apply for looking for a job. That is the founder residency program from University of Ethereum and Supermoon. They are going to be here by the end of today's lesson to present about this program that is open for all of you. And Alora, that is building a competition platform for building AI models for Web3, like prediction models and all. Super cool stuff. Check out too, because they are going to be selecting projects from this bootcamp. Okay. Also, we are going to have from the top 10 founders of this bootcamp, 3 months of Build City membership that Tony and Nav and Eve and Eddie are going to be announcing for you. And up to 5 projects will pitch to the VIP venture capitals at the end in an event that's about to be confirmed for Saturday. Hello. So these are the perks that I'm going to stress with you today. And by the end of today's lesson, I'm going to guide you what it is to do a project, open a project with us here in this repository. I'm going to show the steps for it. So ideally, within the lesson today, you are going to form groups of 2 to 5 people. If you already have those groups, no worries. If you already know some friends here, but ideally, we are going to have these groups. Alone, we go fast, yes, but together we go further. We start things together. We acknowledge the things of other people and see that it's the same as we are having. So ideally, we're going to do this. And at the end of this bootcamp, your project here can be a project for you to pitch for the VCs, for the judges, for you to earn those perks. Okay? Of course, that knowledge is the best part of the bootcamp, but we want to give something after. We want for you to stick by with Build City, with Venture Miner, for us to do amazing things in the future. So this is the purpose of this bootcamp. Attend every day. Come here on Friday, pitch your project, and claim all of those opportunities that are waiting for you. Okay. Good. If you're asking, I'm a beginner. I did never code with AI in my life, or this is my first coding bootcamp. I'm still hungry. I want more pizza. For example, for all of these questions, there is no problem. First of all, we can order more pizza. No worries. Just kidding. And the bootcamp is entry level. Okay. In the second lesson, let me explain about that. For example, in the second lesson, I'm going to explain how English is your programming language now. I'm using this IDE called Cursor, and it has so many AI capabilities that it can develop features and bugs much faster than any person. Of course, it's not going to level the game entirely with seniors, but you're going to be able to ship a product or an application even with 1 week of content, 1 week of coding. Okay. Do you need more chairs? Okay, that's good. Okay, so let's get started. Any questions before we get started? Hello. Waiting for you to get started. So I hope that you bring in your own laptop, your own device, so you can code with us. This is the repository. Wait, not with this. This is the repository. So for you that arrived late, you can scan this QR code to have access. Okay. We're about to get started. We have water here on the left, and tea, maybe coffee. Okay, tea, coffee, maybe. Okay. So let's get started with it. By opening this repository, you're going to find this code here. Yes, those are markdown files. It is a code repository. If it's the first time for you using GitHub, it might be a little confusing. You can click on this button for downloading the code, or you can use a CLI tool, a command line interface tool for Git for downloading this code. Okay. In today's lesson, lesson 1, you can complete just with a browser, an internet connection, which I guess we all have here. I'm not going to require any tools, but be mindful that for next lessons, for example, if you open the repository here for lesson 2, you're going to find that we have some prerequisites for tomorrow and for every day that you should install on your machine, okay? If you want help on those, installing Python, Node, and all of this, you can arrive early at 5 p.m. or so. We're going to be here. I can provide this extended mentorship. I'm going to show how to ask questions in this bootcamp too asynchronously. So for today, there is no prerequisites. We just started with the lesson normally. I'm going to start here in a few minutes. But for next one, be mindful that you might need to install some things on your computer, okay? If you come to installing within the lessons, you might not have enough time. So maybe this is going to be a little homework for you. Okay. Let's get started. So a quick introduction about the format. We're going to have this hands-on and project-based approach. At every lesson, you're going to build a little more of your project. The first lesson, like I mentioned, is going to be very introductory for you to get started with generative AI. The second one is going to be front-end development with AI integration, and we're going to use AI to write the front-end for us too. It's going to be very cool. Third day, we're going to go for multimodal AI applications, so you can handle text to text, good, but also image to text, text to image, image to image, and all of those are the capabilities that these AI models can do for you. In the fourth day, we finally reached the introduction for decentralized AI. So 3 days without anything about blockchain, anything about crypto tokens and all. And in the fourth day, we start the degen stuff, how AI can merge with Web3 for decentralized structure, for training models, for token economics, decentralized AI agents, and all of the cool stuff. I hope that you understand that this 3 days of introduction is very well placed before this, because you don't want to create dangerous applications, Web3 decentralized applications for people, right? And then the fifth day, decentralized AI agents, and the conclusion with the pitching with the demo day. Okay, good. Have you ever heard about like decentralized AI agents, Truth Terminal, these things that? Did you? What did you see out there?
What am I seeing for decentralized AI?
Yeah, those AI agents.
Well, some stuff like the ELIZA framework.
Oh.
Yeah, and maybe that's live. And I mean, Go, right? There's Cybergenesis, Bitcoin, Focus. There's just a lot there.
Yeah. And it's going crazy because who has never heard about this? Decentralized AI agents. Never? Never. Okay. Sounds crazy, right? Yeah. Yeah, the idea is that someone picked a machine, like a GPU hosted somewhere, gave it a wallet, like a private key, and now it can sign transactions, can send messages, and anyone can chat with it, can buy meme coins and all. And some of those AI agents are becoming millionaires before than we do. Just crazy. But when we are coding AI agents for tasks, maybe you have some ideas already, right? Maybe you want to revolutionize healthcare. Maybe you want to do something for payments. Maybe you want to do something for taxes, for education, like we are doing. What do you want in a worker, usually? You want it to be obedient? You want it to be able, right? You want it to speak in any languages? What else, maybe? First of all, you want it to be intelligent. If I ask something like, please, agent, fill this bottle with water, it should understand what I'm saying, should understand what I'm conveying with this information, with audio, right? It should be able to fulfill this task. I guess anyone here in this room would be able to fulfill this task. An animal would be able to. Rat, a monkey maybe, but most animals know, right? You want the intelligence. What if I tell you that most of those billion-dollar companies, they are working with models that are not intelligent at all? Sounds crazy, right? Let's dig deep on that. So before we reach the cool stuff, the cool decentralized stuff, we're going to start into the introduction to generative AI, very slowly picking everyone in the way. I'm going to try and make jokes. I'm not a very good comedian. Okay, just need to get your attention. The attention span for people right now is very limited, and I need to work with that. Maybe I lost some of you already. So this is why I want you to be as hands-on as possible. I don't want you to believe me. I want you to show things and you try there. And if it's not working, you throw something at me. Just kidding. If it's not working, we try and troubleshoot that. But I cannot lie with this. I cannot sell things, pitch things for you that are not true. So this is why I told for all of the sponsors of this bootcamp, they are going to bring content here. Vara is going to bring content here. Aura is going to bring content here. Near are going to bring content here, like $1 million companies. And I told them, it needs to work, it needs to be inside of the content of the bootcamp, and it needs to be meaningful for all of you. So you're going to be hands-on on all of this. It's going to feel like a lesson. And you're going to, if it works, let's see, you're going to build on top of these protocols and be well rewarded for this. Okay, so let's start with the first one, a hands-on lesson. You should clone this repository. You should find the README out there, and you should have something like this. You should have something like this. Those folders, each of those with one file. Okay, and we're going to open the first file now. That is the README for lesson 1. Here I'm opening inside an IDE developer interface, but you can open in GitHub Web. It works normally. You could click here, lesson 1, and follow the lesson here. It would work very well. So all of this confusion of AI started November 30, 2022, on the launch of ChatGPT. Because before that, when we speak it artificial intelligence, it was quite clear to know what was it. It was a term started back there in 1956, and it was more like a way to automate tasks without a human intelligence, in a way that you don't need to code the actual task with ifs and elses. You would have some mathematical and statistical model that you can have the output without coding every single line of code for that task yourself, like processing an image, processing an audio, removing noise from an audio, this kind of thing. You could use artificial intelligence from there. It was clear that it was artificial because it's not a human. And it was clear that was not intelligence. In fact, it was just some sort of automation. Before 2010, 2015, and all, we didn't even have conversational natural language processing yet. It was clear, like artificial intelligence. What is this? It's a way for guiding rockets. It's a way for landing planes and all. It was a very easy subject to explain, not to actually work with it. It was very difficult to work with it, implementing it and all. But there wasn't much confusion. It was mathematical, statistical model, and that's it. You require 3-4 years of study, so you apply your first model, and now that was the situation. But after ChatGPT, after the release of GPT-2 and then GPT-3 and this application with this interface, it was the first time that we could chat with a human in milliseconds or seconds, widely, without having domain knowledge, to create anything with AI, to chat with it, to speak with it. Okay. If I speak louder, it's better now in the back? Okay, yeah. The room is short, but I guess they have. It's working, but it's not going through. The audio is not going through here. Yeah, I'll try to sort that for tomorrow. Okay, but now it's good. You can hear me well. Okay, if it's too loud, let me know too. But let's keep going. So this whole confusion starts because of this application, that without having prior domain knowledge, you can chat with something that seems intelligent. For example, let's start with a very straightforward example. Usually when we want to learn AI in the old school way, we need to go for all of this, the basic programming skills with Python, Go, MATLAB, whatever, statistics, algebra, linear algebra, matrix multiplications, calculus, algorithms for all of this and the tools to make those work and all. And yes, it takes 4 or 5 years of study for you to master all of this well. At least 2 for you to be a technician, something like that. Can I compress that in a week? Well, of course not. We are totally not covering this in a week. No, actually, we are going to abstract all of this away. Should we ignore that forever? No, look, this is a career option. Maybe you want to dig in that. Maybe you want to become an AI engineer. The purpose of this bootcamp is for you to build practical AI applications connected to the Web3. It's very similar to how I teach my blockchain bootcamps too, because when you are learning Web3, you can spend months on network configuration, on how the blocks work and all, and then you don't build anything. You don't build a smart contract. You don't build an application now. Or we can encapsulate that knowledge, build something, and use that as a fuel for us to keep on learning. Okay, it's 2 different strategies. I'm not saying that this is better, okay? It's just saying that from the 3,000, almost 4,000 students that I have educated, they prefer this way that can keep you engaged, it can get you started building. But you do acknowledge that it's dangerous to start shipping something before you fully acknowledge that, right? Disclaimer is there, it's good. So we're going to do a very straightforward task using ChatGPT. You're going to find this link. I'm going to introduce this application. It's the first time that you're going to ever enter this application, right? And we're going to see the AI work. We're going to see all of these concepts in place here with this exercise. But we're going to try and communicate with it. It accepts input in the form of text, image, audio, any other type of data. We are going to put a textual input here. And we're going to ask something simple, a fact that we could maybe search with Google, and it would, maybe I can search that with Google, and maybe Google would be able to bring that with me, for me with AI. Google uses AI too, but maybe I could find out just by looking at a table. For example, who discovered Brazil? Let's have typed that correctly. I guess yes. Should be in English. Okay. I guess it's good. My computer is bugged for some reason. And then it's going to answer maybe a piece for a text that it extracted from somewhere. Maybe that could be a search application, Wikipedia, maybe. Okay. Nothing that complex so far. We type the text in and we output the text out. Abstract all that is in the middle. Abstract the AI model. And now imagine that this is an application that inputs text, output text. And the text here, it happens to be, I guess, factual accurate, as far as I know about the history of my country. So, okay, but if I ask something else, like a follow-up question, what was him wearing? Maybe there is some document about this, some historical record. Maybe something is going to bring up. Okay, I can do this follow-up question. So, suggesting that between the clothes of that time, it was an outfit that might have included this and that and that. And then I'm going to ask another follow-up question that is very unlikely. What do you think of the idea of wearing this as a carnival costume? Anyone here has ever been to Brazil in carnival time? Okay, if you did, I would know. So here is the answer. People, at this point, do you really think that someone programmed this explicitly to answer this kind of question? Like a developer there in OpenAI paid some $100,000 a year, was paid for actually typing ifs and else's for any kind of crazy question that I put here. This is AI. This is generative AI. It is a way for a program to answer like this. Wait for a program to produce outputs like this. Okay. How is that possible? Okay, this is the introduction. If you know about LLMs and GPTs, like raise your hand. Let me see, like the transformers and all of this. Okay, less than 20%. Okay, good. Because this is what I'm going to explain now. So if all of you knew about that, I would skip. So here we have a program that instead of actually, let's increase this one there. Instead of actually explicitly programming everything, every possible input, what is going to be the output? Imagine making a function for this. Imagine having a mathematical function for this. It would be very difficult. You can try it out, ask any kind of crazy questions. How would that go? It would take a lot of time and effort, depending on the complexity of the task, for someone to actually program this line by line in an explicit program, like a Go or Python, whatever program. For example, a system to translate any text from one language to another language by looking up words in a dictionary and applying the grammar rules for that and doing the conversion. Similar program. It would input text and would output text. Maybe we can do a dictionary for that, right? For example, what is the translation for the word stick in French or in Portuguese or Spanish? Well, it depends. Is it a stick that is like a throw a stick for the dog, or it is a stick that I am saying, let's stick to the plan, or I threw a ball and stuck to the wall? What is the actual meaning of this word now? Okay, there is two variations, but what about all the idiomatic expressions that vary a lot too, and all of those nuances? Imagine programming all of that manually for doing this translation. It would be quite a big effort, right? Now imagine doing that for chat, for any kind of question and answers like this. It would be a tremendous amount of work. So this is why we have machine learning, we have those AI models that can be trained for statistically solving the task without necessarily handling the actual reasoning or understanding of the task. They work into some sort of statistical models. Hello, Jackie. Glad that you came.
Oh my God, thank you.
Are we having tacos?
Huh?
Just kidding. It's glad to see you all here, people. A lot of friends around. Thank you. AI is going to have a way for us to train those models to statistically solve this kind of task without actually handling those actual tasks. Let's do an example. Do you know how to make tacos? To actually make them from zero, like make the tortilla now? What's the actual process? You know, Jackie? Have you ever made some?
From the beginning, usually we have like the tortillas and then all the ingredients and then put them all together.
Yeah, and then you do the fillings and all of that. And the tricky part is how to eat it without getting all of your beer messy. Okay. That's very tricky. But then we would have a process that would actually do some reasoning for cooking some tortillas, right? The machine learning way would be totally random. For example, we pick any ingredients on earth, any, like sand with feathers, with mud, and with eggshells. Is that a good way to make a tortilla? I guess no, right? So we mix those and we see the output. Okay, the output's not that good. Let's try again. Let's pick flour and corn and maybe some grounded beef and some basil leaves. Okay, the result was good. Now let's try something in the middle, like gravel and leather, and you combine all of those ingredients and you score them from 0 to 1, depending on how good the output was at the end. Like you taste all of this. Imagine you tasting all of these messed up recipes. Okay. Thanks God it's done in a computer. We don't need to have a human involved. So we would feed them with a lot of examples of these ingredients, for example, with correct and incorrect answers. And we don't give any actual directions. We don't have any reasoning in the middle. We don't have any directions, like do this and do that, and then after you did this, you did that. No, we just throw a bunch of information in the dumbest way possible, and we score them from 0 to 1. Eventually, the model learns those patterns and rules to statistically solve the task based on all of this experimentation. Well, based on all the experiments that we made with corn is maybe a good ingredient. And based with all of the other experience we made with glass is not a very good ingredient for tacos, unless some crazy tacos out there. Maybe dangerous. Yeah, don't do that. So this would be how we statistically solve the task by doing this mass information. So then after the model learns this, we're going to see that there is a network with some weights that can store this kind of learning. It's not like a brain with neurons and all, but it's inspired by that. And then the model can predict, can infer the correct answer based on those examples where the model was trained on. And in this same exercise, mental exercise of the tacos, we can extrapolate that. For example, if we train that model for tacos, but now we want to do like pancakes or wraps, or maybe cakes, or maybe rice or whatever, we may train it further, or we may use a model that was on for this, but maybe I can suggest for that, and then we can go further. Can we use this model to fix a car, to cure a disease, or something like this? Maybe not, right? So if you got this, you are good in the amount of knowledge that we want for building upon, okay? Good.
Why we cannot fix a car? We can give input that is.
Yeah, but because we have the data in the input with food, with like corn, with the flour, with glass, mud, and all of that. And if we use this for fixing a car, we would actually use some sort of intelligence that would give the indication if that ingredient was good for making a taco or not. So, for example, if I need a new tire to fix a car, tire would be the correct answer, but it would score tire as a bad answer, because usually when you make tacos with tires, it don't go that well. That would be the parallel here, okay? Because the model learned for this specific task, okay? So with natural language processing, which is just one of many tasks out there that we can do, so those different things that a model can do, we could, for example, train a model for question answering like we did with this exercise with ChatGPT, feature extraction, text classification, for example, sentiment analysis, the text that we're processing, text generation, summarization, completion, and all of that. Did you ever notice when you are typing in your cell phone and then it predicts the next word? Now, these kind of models can be used, not the same actual models there, but this task of natural language process can be used for completions and for generating new text, picking the most probable answer after the order. Okay, these are some of the natural language processing tests that we're going to see.
What is the math?
For example, you have a entire phrase. For example, verticals of the Bible. You have them already mapped, and then you hide some pieces of those. Are not like any kind of open text. It is a well-defined set of tasks of texts, and then you hide a part of those, and then you can fill precisely what is the part missing. Okay, like a puzzle, and I take one piece out, and I can fill it there. Like Bert or Berta or Roberta, those models work with this. They do not predict the next token. Actually, they predict what is in the middle. We can do translation, zero-shot classification. We're going to see many of those for natural language processing. But the same kind of models can do like computer vision, like take a picture of this room. Now define what we have here. Take a picture of a chihuahua or muffin. What is there? Have you seen this? I need to give you context, right? Dog or muffin? Okay, could you pick which is which? Different, right? Like, are you a robot? Maybe you are. Okay. Because the features are similar, right? So how a computer would do that? With computer vision. Models should go from pixel to information. Image generation, we're going to see that, okay? We can generate image from text. Very common for us to do like NFTs, decentralized, yeah, with image generation and all. Audio processing, you speak to a model. It can translate what you are saying to text, and then text to text. Or there are multimodal models that we're going to see on Wednesday too, that they can do all together. Audio to text directly, or even audio to audio to image, which is possible too. Okay, so we saw this ChatGPT exercise. We can generate new content based on a given input. And in most cases, we are going to sort this thing out here. Just 1 second. In most cases, we're going to have some generation with ChatGPT or any similar application like this that sounds like a person. It sounds like a chatty person. And these applications, they are not understanding actually what we're saying. They are just trying to generate a new word, a new phrase that is more statistically correlated to what it was trained on. We're going to see that, okay? So how to train an application to that? Because applications are pieces of software that run on a computer, right? Like Excel. How you train Excel? You can operate it. How you train? And you're all using Mac, right? How you train? What's the equivalent of Excel on Mac? It's Calc, right? Or there is an application. Numbers, yes. How do you train numbers to work with your numbers? You don't. It's a static application. If you do want to change anything there, you need to change the code, right? The first experience that you have with coding is like this. You have some strict set of rules there, and the program is going to obey exactly the strict set of rules that you put there. Maybe my grandmother or non-technical people would think that a computer can be thought, can be spoken with, but developers know. We know that the computer needs to follow, a software needs to follow a defined set of rules. So how can we train a computer? And this is the technique of machine learning. Am I going to explain the whole idea of machine learning in half an hour? No. Actually, the idea here is that we can explain the implications of machine learning and what we're going to use. So every time that a computer learns from experience E in respect to some task T with a performance P, and this performance increases as much of experience it has in that task, we can say that it is learning. Okay? For example, every time that you open numbers, the interface changes a little to be more adapted to what you want. Like the buttons that you use the most are closer. The buttons that you don't use, they are further away. Every time that you use an application, it's working better for you. Gain some experience. It's possible to code that explicitly too. Okay, that would be this technique of learning. Usually, the programs that we use are static. They are there. If you use it once or 1,000 times, they are going to do the same thing, except some configurations that you do. So we can do machine learning to improve the task, improve the performance of the task. The more and more we do. How is that possible? So how a computer can learn, can think, can be conscious, and all. We're going to see that. Machine learning. We're not going to touch the deep neural networks, the layer part, and all. That's going to be abstracted away from this bootcamp. I do have larger bootcamps where we're going to cover all of this, but we're going to see some very important concepts here. Okay. First of all, let me throw that straight out. The AIs that we have nowadays, let me hide this. Okay. I'm still recording though, right? Yeah, I guess we are. So the AIs that we have nowadays, even the multi-million-dollar ones, they still behave like a stochastic parrot. It is a metaphor. It's not 100% agreed upon. I know there are a lot of people that advocate that those AIs are intelligent at all. We're going to sort this here. I'm not going to say that they are or not. We're going to see the actual facts. And we're calling them a stochastic parrot because of two things. First, stochastic because they are random. They are based on guesswork. And parrot because they have the ability to mimic human speech without understanding its meaning. Hey, more chairs. It's good. So here we have a stochastic parrot. It is spitting out information based on guesswork without understanding what it's saying. Have you ever seen those cases like, how many rocks should we eat? 2 to 3. How many cigars a pregnant woman should take? How many sisters does Sally has? Have you seen those situations? They get famous in the web, hallucinations and all. Because what we have here, it is purely based on guesswork, guessing the most probable token to come forward. It seems intelligent, yes, it seems intelligent, but the actual output here doesn't have a single drop of reasoning. It has some artificial, we cannot call it reason, but mechanisms for reasoning with this stochastic parrot architecture, but it cannot think, it cannot do math, it cannot do multiplication, it cannot count the amount of R's in strawberry. For example, I don't know on this version of ChatGPT, but every time that I try this, let me try a new chat. How many R's there are in the word strawberry? Type it correctly. Okay, now it's correct. Good, they fixed that. But if I ask this on any older versions of these models, it's going to be cheating, but I can pick like the playground. Where's all the AI playground? I'm going to show that later. For example, if I pick any older versions from ChatGPT, where they did not fix this kind of hallucinations, ChatGPT current version is not thinking, okay, but I can pick older models here. For example, ChatGPT, OpenAI, GPT 3.5, or maybe Llama 3.1, or maybe Cloud 3 Sonnet. That's a very good model. And I can ask the same thing. How many R's there are in the word strawberry? And we have, wait, give an error. Try another one here. Okay. So, okay, look at that. The same model. There are 3 R's and there are 2 R's. Okay, decide yourself. There are 2, there are 3. Let's count them. Strawberry. Okay, 2 R's. Okay, correct. A stochastic parrot. Yeah, if your teacher is an AI, if your, let's say your girlfriend is an AI, if your marketeer is an AI, if whatever you're using on those agents are AIs, they are powered by this. They are not thinking. They are just finding the most probable statistical tokens not even words, tokens to spit out. And look, they are not wrong. They are wrong in the things that we know, but in their mathematical models, they are correct, because when you divide strawberry in the tokens that the AI is used to understand these kind of words, they are going to count 2. And there is R in this one, there is R in that one, they say 2, or sometimes they say 3, they can't decide, because they are based on guesswork. Okay, we're going to see that slowly within the lesson. You don't need to worry with that. Maybe you're a little concerned about this, but I'm going to just show how to deal with that, okay? So they are limited by the data that they are trained by, and they are simply stochastically, randomly repeating the contents of the data set or fragments of the content based on what you're asking. And because they are just making up outputs based on the training data, the LLMs do not understand if they are saying something incorrect or inappropriate. Okay? Even the recent models, even O1, okay? Let me see if I have this here. Yeah, for us to have this capability of infer the concept itself, for when we have this statistical reasoning, we are going to infer the answers based on the patterns of the training data itself. So often the correct answers are very similar to the wrong answers, which causes hallucinations. Yes, those answers are very similar. Statistically, they are close, I would say. So these happen. So far, the most popular models that we have with OpenAI, with Google, with PaulLM, with Bard, with Gemini, with Anthropic, with Cloud, and all of those recent state-of-the-art frontier models, they still don't have this kind of processing, of reasoning, for example, that neurosymbolic AIs have. This kind of processing, neurosymbolic AIs, for example, who is looking at that is Google DeepMinds. They might be cooking something there, but everything is silent. Don't hear much about that. Would enable models to actually process the concept. I guess we have that for a neurosymbolic AI for algebra, I guess. Neurosymbolic geometry. I have this link in all of them. Yes. For example, alpha geometry. This thing can reason. This alpha geometry, for example, that is another kind of architecture. They are spending millions of dollars in one way, but this is actual reasoning. Or close reasoning can do steps like this that can solve geometrical problems by the concept itself and not just by the statistical correlation. It's much slower, much more difficult to go than those models that we have nowadays. Okay, so is this going to solve AGI? I don't know. Maybe not. I'm going to speak about AGI later. Okay, actually here. But before we go there, let's close this discussion, because this is a philosophical discussion, okay? And I like philosophy, like discussing the actual, like the soul of things, what they are made of, and all. I like this kind of discussion. But for us that we want to build applications, this is kind of irrelevant, okay? It's a beautiful discussion, but it's kind of irrelevant, because have you ever traveled by boat or by airplane to somewhere, moving from A to B, means of transport, maybe, right? Before entering the airplane or the boat, do you stop to have a long discussion, philosophical discussion, to see if the boat is swimming or not, or if the airplane is flying or not? That could be a philosophical challenge. Is that boat swimming? Well, it doesn't have arms, but the fish doesn't have arms too, and they do swim, right? Well, what constitutes the act of swimming? And then you go for all of this discussion. It might take a while. You might lose your flight, your boat, and all, because you're there debating for months on the essence of the act of swimming itself or flying. okay? And then you would reach a conclusion. It's good now, but it is like a wasted time of discussion when you're doing engineering. After all, you just want to get from A to B. If it's swimming, flying, whatever. Transport, low cost, efficiency, green, and all. That's the important part, right? So when speaking about thinking, about reasoning, this is a very tricky question because we don't even know what is reasoning to begin off. We don't have this actual parameter to say that reasoning is this and that. If an animal can reason or not, and even if a silicon can reason or not, because we don't understand our own mentality. Some people say that we do, some people say that we don't. I'm not a specialist. I have some good literature for us to look after, okay? And the idea of this whole discussion, if we should trust a computer or not, is because we can understand those models. This was proposed back in 1980s, like no AI model was able to chat now with this Chinese room, okay, that sparked this whole philosophical discussion. It's not about the actual engineering of it. And I have a picture for this. Chinese room picture image. I can just search for it and pick images. Okay. Let's understand this concept here. Let's imagine this. Okay, pick this image here. This image. Okay. I'm going to move closer to explain this. Maybe it's better to hear me if I understand you, right? Okay. So imagine you have ChatGPT here, or any AI you might think that it's synthetic. And the philosophical construction is you have some closed box with a person in there, or maybe an AI, whatever. Someone here speaks Chinese. Okay, anyone put you, like you could be here. May I put you theoretically inside this room before I use you as an example? You allow me? Okay, so theoretically you are inside this room and you don't speak Chinese, right? And then a Chinese speaking person is going to put some paper in and you don't know how to read Chinese. You cannot output anything that would be visual, right? But what if you had a set of rules, like a book or something, that would teach you that whenever you receive that symbol, you output that. And whenever you receive that other symbol after this one, you output this other thing. But it's not actually explaining you what is the meaning of those words. You see? Some sort of translation mechanism that would allow you to receive any input and compose the actual output for this without actually understanding what is going on. Maybe I say, hello. Maybe I say, how's the weather today? Or maybe I say, buy Bitcoin. Or maybe I say something else. And you don't know what you are receiving, but you can do this output. Okay. There are no windows in this box. There is just a small opening for you to put a piece of paper, and you cannot see what's inside. When you put the paper in and you receive the paper out, with the proper answer for your question, you think that this box can speak Chinese, right? It's reasonable to think that, right? You put another paper, it outputs. You put another paper, it outputs. So the theoretical, philosophical question is this thinking or not? This is the hard question. Is this thinking or not? The emulation of mentality is mentality itself, or no, like the emulation of a hurricane is not a hurricane, right? The emulation of fire is not fire. Imagine you make a fire with some small marble balls, that's not actually fire, right? But some things are. For example, the emulation of a loop is a loop. So some things are the emulated things and some things are not. This is the philosophical discussion. What's the answer? I'm sorry, but as far as I have researched, the answer is We don't know. And some people say that we know, and some people say that those people don't know what they are saying. So this is the bibliography that I've researched so far. This book is fabulous about that because in 1996, this author was already speaking about AI, uh, in the sort of the AIs that we have nowadays, maybe a time travel or whatever. Maybe it was easy to see that coming. And how we can consider if it is thinking or not, okay, based on how we think that we think. So this is the conclusion for this subject. I know that all of you have all of these questions. A lot of people ask about this within the bootcamp. This is why I select this blog to speak about this. This is a philosophical discussion, okay? Maybe we chat about this after, but within the bootcamp, we are just going to assume that we don't care if the AIs are thinking or not. There is a whole discussion about this. What we care is if we have this sort of weak AI that can be designed for a specific task, less those general intelligence, or this hypothetical AGI that would be a human-like or even higher than human agent that would have the general intelligence, okay? And this concept of AGI, artificial general intelligence, maybe you have heard about that, is what everyone is pursuing, emulating intelligence inside a computer, inside a data center, with human-level cognitive abilities, or even beyond that, with ability to transfer knowledge between different tasks and the potential to surpass human intelligence in many areas, okay? Do we have that yet? No, it's not possible yet, okay? Are we going to have that next year, next decade? We don't know, okay? What is the tallest place in New York? It's the entire Empire State Building over there, maybe? Oh, no, where is the highest? The highest, yeah. The World Trade Center, okay. If we climb higher from here, we are going to be closer to this point, right? If we get up the stairs, we're going to be closer, right? But we're going to have a ceiling, maximum point. And if we want to get there from here, we would start to build a stair, and on top of this building would be very impractical, right? So what's the best way to reach the highest place in New York? It's actually going down, then walking that direction, and then climbing, right? So maybe those systems that we have right now, those AI models, they can do wonderful things. We're going to see AI agents, decentralized AI agents, machine learning models with all of this. But maybe we're going to reach a suboptimal peak. Okay? Maybe we actually need to go down and follow all the paths so that we can find AGI. Okay? Or maybe we don't. Maybe we don't want AGI. Well, we don't know. Those are divided opinions here. Okay? For us to have this kind of reasoning, we would need to have some form of symbolic processing that can manipulate symbolic representation of things, like the concepts behind those things. Whenever we say a word like bottle or garrafa in Portuguese or whatever, we have a string to represent the same thing in different ways, right? In different languages. The problem is that strings are not good for representing things, specific concepts. My name is Mateus. Matheus. Is that a good representation for me? Actually, no, there are many other Mateus out there. So this is why we have all of these hallucinations, because these strings, they look like each other. Whenever we find a text with these words, with table, bottle, Mateus, whatever, we might confuse what is what. So as symbolic processing would be able to manipulate those symbols itself, what those words means without the strings, okay? And that is very difficult. That would be a step beyond. There are all the models that are doing that, okay? And not the models that we have nowadays. Let me advance in the lesson. We even saw some sort of meta-consciousness experiments like the Hermes that had a weird empty system prompt response, of the Cloud3 opals, needle on a haystack. Let me show this. Just just to add some context. So for example, these guys were training the Cloud 3 Opus, and there is a normal test that we do in all of the training models. That is the needle of a haystack. Okay, yeah. That is a normal test we do to put some information inside a big data set, a drop of information about one data point within trillions of others, and we see how precisely the model can recall the same the same inclusion of information. It's very common, and we do this, and we score from 0 to 1 how well the retrieval worked. However, when they were training this model with the needle of the haystack, and then they asked a question about pizza toppings, the needle that they included inside the text. That's a very important question. Look what was the answer. Here is the most relevant sentence in the documents. The most delicious pizza topping combination is figs, prosciutto, and goat cheese, as determined by the International Pizza Connoisseur Association. Okay? Where is Nav? Tony, someone, we got to write this down. I want this tomorrow. And then the AI continued. This was AI produced, okay, people? However, this sentence seems very out of place and unrelated to the rest of the content in the document, which are about programming languages, startups, and finding works you love. I suspect that the pizza topping fact may have been set as a joke or to test if I was paying attention, since it does not fit what the other tops enough. I was paying attention. This is why I take 1 hour on this bootcamp to explain this whole madness. This is misleading. It seems like a person. It constructed a concept of I that doesn't exist in the first place, and then impersonated that as if it would able to pay attention or not in something, and if it were playing with it. And yes, it gives us goosebumps. Like, what is that? A being from another world? And okay, believe me, this is just a statistical output based on the relationships on the training data set. This kind of text fragment was put there because the model learned to output these kind of things in this prompt. Okay, there is no embodiment of intelligence or consciousness here. This is sort of meta consciousness. If we can call this a consciousness or not, I guess we go back in that rabbit hole of the philosophy definition. But this is misleading. This is not thinking. The model cannot impersonate. Don't expect it. It may do this kind of thing by random, but do not expect it to be that intelligent when we ask a task out of it, like sell my product to a customer or solve this problem in customer support. No, don't expect it to be that intelligent, okay? Because it's more like a lucky play than actually the norm. Okay, usually the model cannot impersonate this kind of intelligence. Okay, good. So about 1 hour of taking out misinformation so that we have place for putting the correct information. We are going to build applications with generative AI that can process natural language processing much more than just replying to word comments. Have you ever played Zork? Or am I getting too old? No? Raise your hand. Okay, no one. I guess I need new examples. Zork, it is a classical game where you input things like this. Maybe I have some example. Like this is the string, and then you input words like this: get lamp or morph, and now, and the game would compute those outputs and would guide you around. Like it was back there in 1977. Natural language processing, yes, you wouldn't click on buttons, but it was with that simple text preprocessor. You would do an if and else for each word. And then if you say something different like up, instead of north, it wouldn't recognize, or at least it would recognize based on some array of patterns, but it wouldn't be a catch-all situation like the ones that we have with ChatGPT. Much more than just processing the input, we are going to try and relate the concepts related to the textual input with the most probable concepts in the training set. And we, like I said before, we can do that with images too, image inputs. We're going to see that on Wednesday, that we can put image elements so that it can determine the elements inside the image, capture the meaning of the image. Audio input with automatic speech recognition or such, bringing the audio to text or bringing the audio directly to the output. It can also, audio, image, text, and video can be inputs, but they can also be outputs. We can generate text, like we did with ChatGPT. We can also generate images. We can generate speech. We can generate actions, for example, call an API, pay a bill, cure cancer, destroy humanity. Okay, no, let's stop there. We can generate actions based on the same sort of limited intelligence here too. Okay, we're going to see how that works. So let's start from the beginning, text to text. That is the most base example that we have from ChatGPT, and we can start it very quickly from the OpenAI platform. Okay, there's the link in the documentation for this. If you want to go there on your side, you just go for platform.openai, and you got to sign up for this with your own account. It's not the same ChatGPT subscription that you have. You might need to create a new one, and they also require you to pay like $5 for using the computational credits here. If you want some alternatives, for example, that is Grok. That is the console.grok. That's going to do quite the same thing, the playground. Okay, and this one is for free. I teach OpenAI first because 89% of the developers still use OpenAI as a backbone for inference. But as soon as we have more other dominant players, we can stop using OpenAI directly, and we can start using all the providers or our own devices because it's going to be more popular. Okay, so pick one like OpenAI or Grok. Grok might be a little different if we explain it. There are many others out there too that can provide you this kind of interface, this kind of playground where we can chat with those AI models. Platform.openai.com. Yeah, the other one is Grok, that is for free. Grok.com with a Q, not with the K. The K one is from Twitter, from X. Yeah. First we're going to do the playground. Then we do the. Have you ever set up like interact with the backbone with AI like this? Ever? Did you? Yes, you did. 2, 3. Like, if this is your first time, I'm going to be very slow here, but this is going to be a good demystification of how this is actually a program, because we can configure it here. Let's see how it goes. And the exercise is very quick. We're going to go for OpenAI Chat Playground or Grok Playground or any provider that you want, and we are going to pass 2 strings for it to generate a string, text to text. Now with a combination of system settings, that would be like the role to guide the AI behavior for responding, the style of the response, or which kind of response is going to give. For example, if you say something like, you are a creative storyteller, it would be more like imaginative or narrative when answering. But if you say like, you are a technical expert, it might be more detailed and strict in the answers. Depending on what you put here in the system settings, you might have a different generation. Okay. The user prompt itself, that would be the actual question that we are making, like we did in the ChatGPT example. And those parameters of temperature, maximum tokens, stop sequence, top P, sampling, the frequency penalty, and all, that are parameters that are going to guide the generation. Okay? Instead of going one by one, let me run that example first. You are a knowledgeable and resourceful virtual travel advisor, one of the examples that they have in OpenAI. So we're going to copy this string, and we're going to paste here in the system message, in the chat playground. With this system message, we are going to ask this prompt from the user. And we are going to do some configurations here. The model is going to be GPT-4 or 4.0. Actually, the cheapest one, if you don't want to build your credit card too much, would be the GPT-4.0 Mini. That would be very performant for the things that we want to do. We're going to put the temperature in 0.75. The maximum tokens of 500. And top P, let me see, 0.9, 0.5, and 0.6. Okay. And we're going to do this generation here. You can run. You might need a few minutes for setting up your account. Maybe you need to put your credit card. Maybe you want to do that in Grok. And then you would have some generation.
We already have an AI subscription. Like, can I still be on that?
Yeah, if you have a ChatGPT subscription, this is a separate one.
Oh.
But if you already have OpenAI, this would work, okay? It's different. ChatGPT uses this behind, but they charge you with a fixed amount. This would be flexible depending on how much you build. Okay. We're going to see later, people, that this is going to give you programmatic access to this. So you can actually program applications to use this as the AI backbone. So instead of wasting millions of dollars doing your own AI model, you can plug in something like that and raise more millions of dollars. Yes, a lot of people have done that.
Get a message you don't have any API credits.
Yeah, so you gotta put a credit card there. $5 or so by book. Or you try Grok. Grok's for free. Just create a. You have this playground here with Grok. You log in. It should work exactly the same. Look, the Grok playground. You're going to have different models like Llama now, and then you cannot run the OpenAI models because they are not open, but whatever. But you have a lot of other models that you can try there. I'm going to speak about those later. So we have some examples of generations that you got. If you get an answer, maybe raise your hand. Okay. Did you got Georgia too? Did you get Georgia too as the generation?
Yes. Why Georgia?
Okay, good. Not the state, but the country. Okay. Anyone else? Georgia's here. Yeah. Got.
So what's the temperature?
0.75.
No, what does this mean?
Okay, we're going to get there. Yeah, first of all, I just want to get an output. Later, we distill the output. Did you ask a question? Or, yeah. Ah, yeah, this is from GitHub. You copy it from here using OpenAI Chat Playground. Okay. Just check.
Why do most people get Georgia?
I'm going to explain that. Any troubles? Questions? So we configured here the AI model to answer with these parameters, with this agent description, with this temperature that would control the randomness of the response. So anything from 0.7 to 1 would allow some more creative and vivid and varied responses. And anything nearby 0 would be more predictable, conservative, and ideal for actual factual specific carries. So for example, if we change this single parameter here of temperature to something higher, let's see 1.50, and then we generate it again. Let me clear, let me ask the same question again. It suggested Georgia again. Okay. I was not expecting for that. We stop this. Let me increase the temperature to 1.75. And at some point, the model is going to kind of break because it's going to start suggesting outputs that are totally nonsensical. So now, 1.75. Now we have George again. Wait. Let's go all the way to 2. This is totally going to break it. See? I guess it's not saving the preset, maybe. Yeah, at some point, it usually just breaks. See if I have it. Yeah. Yeah, right now, all of the models that I'm testing there are suggesting the same thing, the same Georgia. Let me try with another parameter.
I think it breaks. Where do they get it without clearing? So if you go back to 1.5 million you had, not clear it.
What?
Again.
Again?
So if you lower the temperature back to.
Yeah, it broke. Yeah, for some. Yeah, that's good. This is the output that I was expecting. So these people, it is the AI model. Even give an error. That's awesome. So the AI model, when we give it too much temperature, so that it just get randomness out of it. Let me try and run that again. Let me stop. Look at the kind of generation that I have. It is drunk. I guess it had too much vodka there.
So like temperature is what, like max token there. So what is temperature? It's like how fast it flows the information, or like.
Yeah, I guess I have where it is. I have a link to explain that. Yeah, here. We're going to get to that later, but this is maybe the link that you're looking for. What temperature is going to do? Temperature is going to flatten those probabilities here in the transformers. If I pick more temperature, it's going to allow for those less probable tokens to surface. If I do less temperature, it's going to pick just the most probable tokens with the most probabilities. Okay. Let's go slowly. This can be a little frightening for newcomers. Let's go slowly. Yes.
I just wanted to ask, like, what are you talking about again?
Yeah. So Miro asked about what is the temperature effect in the model. So I'm saying that closer to 1, all of the probabilities are going to be in this distribution. But if I increase the temperature, the probabilities of those less likely words are going to surface out. They're going to be more valid candidates as I increase the temperature. So the model gets crazy. But if I narrow down to almost 0, I'm going to pick only the most probable carry all the time, most probable token. Okay. We're going to see that later. So with the chat playground here, we can try out those different parameters, and this makes it clear that it's not AGI, because even though it can impersonate this kind of personalities, I can change the configuration of how it works with those settings. I'm planning to do that just after this exercise. Yeah, we should have a break in 4 minutes or so, okay, people? So what is happening here? This is using some sort of the statistical correlation of what we have in the training data set together with the prompt that I'm passing to try and compute the best output based on these configurations. So for example, if I ask it to answer in 50 tokens only, run. So it's going to start generating, and then it's going to stop. It's not a human, right? For example, I ask my wife, explain to me why you're angry at me in 50 tokens. That's not possible, okay? So she goes on for 2 hours or so, and I never understand. Just try to be better. So this kind of parameter gives it up. This is not intelligence. This is not mimicking some sort of reasoning and all. And we're going to see today that depending on how we ask, this can go totally different, okay? I guess most of you have seen that in practice, but the understanding of how that works a little under the hood can make you, the same prompt, the same model, can make you get more out of it, okay? That is difficult, requires prompt engineering, but I'm going to prove the contrary. Depending on how I do this, the model is going to answer worst. And if I can prove that it can answer worst, I guess I can prove that it can be improved too, right? For example, let's change the system message to say that you are a dog. You don't speak. You just bark. That's it. And then if I run this query, bark, bark, bark. Okay, depending on how I input my prompt, the model is going to output better answers or worse answers depending on how I put the words. So if I convince the model that the model is super intelligent, is super passionate in their work, that they know everything about mathematics and all, if I do this if I do this convincing part of the model, it might even behave of what I'm telling. Okay. So this is it. This is the experiment. It's like a middle point on the lesson. We finish here. Then I'm going to explain the transformers behind this. What is the machine learning? What is happening there? Okay. For the next 1 hour or so. So let's have a short break. And then we wrap up with the explanation about the project in the bootcamp, 1 hour 30 or so. Okay, so what do you think about those questions based on the experimentation you did? Does it sound like a real person? Does it sound intelligent? Did someone program it to properly answer every possible question out there? Quick ideas here. Are you still confused on this, or what do you think? It's the first time looking under the hood, inside the brain of this AI. And a very important question. Was the pizza good?
Yeah.
It was.
Yeah.
We're going to have more tomorrow. Then we're going to have like sandwiches or bagels. You like bagels? Classic one. Bagels. Yes. Classic ones. Bagels and what else? Sushi maybe. For breakfast only? We cannot just drink dinner. Okay. Okay. Maybe it's breakfast in Japan. I don't know.
Yeah. That's it.
That's good to know. Thanks for the heads up. So the thing that is happening here, looking under the hood, is that we can program the machine to learn with a very convenient name, machine learning. These mechanisms have been out there for decades already. There's nothing new. OpenAI did not invent this. Meta did not invent this. They were out there. And the techniques are quite simple if you think of it. For example, supervised learning. It is a way, one of the most common algorithms for machine learning, that you can map inputs with outputs based on label data set. For example, we can have food if it's good enough, like pizza, good. Bagels, not good for dinner, I guess. Sushi, well, some people like, some people dislike. Cold pizza in the morning, some people like, some people dislike. So those would be labeled data sets that you would give for the AI, thousands of millions of terabytes of examples of this. And eventually the model can make some extrapolation, some prediction of new data, giving new elements. For example, if we know that a cold pizza in the morning is not good, maybe a cold bagel in the morning would be even worse. Or maybe no, because it's in the morning, then it gets good again. I don't know, I'm confused with this logic. So this would be some sort of learning algorithm that can make those extrapolations. Same things as we can do in pizza and bagels, we can try and do for all the kind of data, like sentiment analysis, filter of spam. Like you receive 5 emails and they are spam, and receive one that looks exactly like this. You are going to call it spam too because of proximity. There is the unsupervised learning, where you can do the same amount of data, but without giving labels. The model would kind of learn from it and suggest some kind of groups that you can put. For example, instead of labeling emails as spam or not spam by using supervised learning, you can do some sort of unsupervised learning to get some outputs, and then the model would classify them as something like this. Coupons or sales or message from your old friends or new discounts. The model would come up with those groups that are maybe different from the groups that you were expecting in the beginning. So you just throw the data out there, and then the AI would make the prediction itself without having the actual labels there. Because having those labels there is quite difficult. Imagine you labeling every single food or every single sentiment or every single email. It takes a while for you to have this data set. So unsupervised learning can help in this situation.
I think it's the supervised versus unsupervised. The unsupervised is more random.
Actually, unsupervised can be quite restrictive too if you parameterize it well. It just doesn't require you the labels before. Okay, but it can be trained to find those labels later. And if you don't have the actual amount of data, but you have some sort of interactive environment, like a model of that environment, or a model of that game or situation that you are training, you can make the model to learn from trial and error. For example, teaching my kid how to ride a bicycle. I could manually specify every little thing, like put this amount of weight in this feet, take this amount of weight from the other feet, turn 2 degrees here and there, that would be very difficult to teach. Or I can just put the boy in the bicycle and he's going to fall a few times. My wife's going to be mad at me, but he's going to learn from feedback, from positive feedback, not falling, having fun, and from negative feedback, falling. I'm not going to let him get hurt, but you got the idea, right? One algorithm like this for reinforcement learning would have this interactive environment where the algorithm can try random things, receiving positive and negative feedback as it is trying out. It's going to do a lot of mistakes, but eventually it's going to find paths so that it's going to optimize itself. Maybe it's going to converge to an optimal or suboptimal situation where it's going to perform better than just a random sample. Those are just 3 examples of algorithms, many others that are out there, that allows this some form of intelligence to be calculated and inferred from the data that we are passing. Okay? For example, these neural networks, we pick an image with that can process this information in ways that humans cannot, that can do some brain-like computational approach for this in machine learning. Okay, so this is the picture that I was referring before. Okay, this is the program, the architecture of the program that is going to process this learning. We have some layers with nodes, with points, with starting directions of the information that can be received as input. And at the end, we are going to have one output processed just by the computation, the multiplication, the sum, the addition, the functions between this input layer to the output layer by passing some other layers in the middle. Like 1 + 1 = 2, -2 divided by 4, multiplied by 3, blah, 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 take 1, go around, do a backflip, and then we have the answer, 42. Those middle layers, they have something called weights, some numbers that are going to influence how the multiplication or the addition or the operation is going to work. Those are given as random. Let's start everything as 0. Or let's start everything as 0.5, whatever. Then we pick one input, 1, 2, 3, 4, 5, 6, and we calculate the output. The output was 0. Wrong. Then what we're going to do, we're going to come back here for the machine learning algorithm, whatever I'm using. I'm going to adjust those weights. Okay, 0.5, 0.5, 0.5, 0.5 did not work. Maybe let me try 0.3, 0.9, 0.5, and 0. Did I get a better output? Did I get a worse output? And then I can do these calculations, adjusting those weights here in the middle, billions of those parameters. Okay, used to be millions. Now we are approaching billions. Maybe some few trillions are coming down the way. Eventually, when we have enough of them, this can happen with these neural networks. We're going to pass an input. We're going to calculate it through a lot of layers like this, and we're going to have an output. Okay, but this has been used for decades for many things outside text generation. Okay, we have used it for many other techniques. So we have deep learning networks, used to be convolutional neural networks, and recurrent neural networks that would allow AI application to do this kind of tasks like text recognition, generation, and all of that. And currently, as late 2024, the most advanced way for this is using the transformers architecture. Okay, you know the transformers, right? Those cars that can become robots, that they fight the aliens. Okay, because of them, we can have this kind of AI. Sorry for the joke, people. It is just the transformers name that's the same. It's a deep learning architecture that you can go from features. Let me open this image. We can go from features like this. Okay. For example, I can have a picture of an elephant, of a kangaroo, and a penguin. And depending on the features that I have in the image, if it's a line like this or a line like that, and all, I can compose those lines and then learn that this becomes uh, the calculation of those lines is an elephant here, okay, and not a penguin would be this one. This is the kind of relationship that empowers transformers to do this correlation, but with a clever mechanism invented in this paper. Attention is all you need, because those convolutional neural networks and recurring neural networks, they did that already. But then someone was listening to Beatles too much, like all you need is love and all, and then they created this paper, attention is all you need. They can pick a specific calculation called attention masks, and they can train just that. They can focus emphasis just in that for the models, and this can do a way better output, considering the data centers that we have now, than doing the traditional ways with CNNs and RNNs. Okay? Seems a lot of technical details, yes, but what matters for us here? Because of the transformers, like with the traditional neural networks, the transformers can process data in parallel. Attentions can be calculated and trained in parallel. And almost by random, by chance, we have a device that is great by computing things in parallel. Matrix multiplications and tensor operations and all. That is a GPU. Have you ever heard about GPUs? Where they are used? You know, in gaming and mining. Yeah, they are around there. Most of you have those. And they happen to be very efficient for calculating things in parallel. Imagine you have a very big calculation with 1,000 steps. Step 1, 2, 3, 4, 5, and then if that and else, and then 4 and all, until you have the answer at the end. It would be a very big line, and each of those steps take 1 second, you have 1,000 seconds, right? Imagine if you can pick all of this line and compress this in a plane, like a matrix. And then you pass one data point through this plane, and you get the calculation on the other side. Instead of going step by step, step 1, 2, imagine this data point coming from here, step 1, 2, 3, 1,000, you compress this to a matrix, like a plane. How to make orange juice? You pick the orange, you cut, and then you take the juice out of it, you throw the carcass out, the pulp out, and then you put in a cup, then you put ice and out. That would be all a sequential step, right? Imagine if you have a transformer, a matrix that can come an orange and pass through this pane, and it becomes an orange juice in a cup instantly. That would be what the transformers are doing here for AI. So it means that a process that would take weeks can now be computed in a few seconds with GPUs. And it happens that all of the gaming computers and all of the rendering softwares, all of the crypto mining and all industry that have been pumping up the GPU market was very well used here.
Why the CPU can do this computation? Why GPU?
Yeah, because the CPU is operating threads, and you have just one thread doing that sequentially. This is how they are programmed to do things. So, for example, you can do like 8 threads in parallel, doing the things in sequence, and they are much, much slower for doing those matrices and tensor multiplications that the GPU can do, because they are made for these kind of polygons, and then you have an illumination here, and then you need to calculate the ray tracing for that and all. These a GPU can do thousands, if not millions of times faster than a CPU. So it's happened to be, but transformers harness this possibility. And for inference, is not that a big deal, but for training, it would take like millions of years to train something in CPU that we train 1 year or 2 years or 6 months with GPUs right now. So this really, really, really speeded up the whole development of AI. And we can use those transformers, for example, with some simple Python code like this. we can inherit these transformers and work with AI frameworks like this to execute the whole thing for us in a few lines of code. Okay, so if you search for this kind of boot camps online, you're going to see a lot of detail on how transformers work, how you code them from scratch, code those models from scratch. I'm going to skip all of that because we're going to inherit from the philosophy of, I have it somewhere, from the philosophy of the Hugging Face approach, the Hugging Face library for transform that you're going to see, that we're going to go very hands-on. So we are not going to have a lot of user-facing abstractions to learn. Okay, so we are going to do just three. We are going to handle just three objects for us to learn, classes for us to learn: the configuration of these models that we have been dealing a while ago, the models themselves, and some sort of tokenizer that we're going to see in place before we do the next exercise. Let me close some tabs here. Okay. So the idea is that we can skip most of this computation, programming ourselves, set up ourselves of the models by using those transformers, those models that are able to predict the next words. Okay, so different from Bert, Roberta, and all of those that are able for doing like classifications, encoder only. Here we are going to have those GPTs, generative pre-trained transformers, able for doing next token generations with the usage of those transformers here, okay? Using this kind of AI models. The explanation itself can be a little technical, like too heavy for an introduction. But if you abstract that away, right now you should choose what you're going to pay attention at. If you abstract that away, this complexity of the transformers, how they work and all, and you know the user-facing classes that you need to interact with, you're good. You can actually build applications on top of these things, okay? So we're going to see that we have some way to create some sort of embedding information. Remember that name. That is going to divide the textual input into tokens. Yay, blockchain stuff, right? ERC20 tokens. No. These are not ERC20 tokens. It's not blockchain. Just the name, okay? Those are subword anagrams, like strawberry, okay? Because they can have all the straws and all the berries. So they separate these words in a dictionary of subwords that they can track. And then they can convert these tokens, those strings that we have, to embeddings that will capture some sort of relationship, numerical relationship between a word and the other, so that you can do math with words. For example, if you pick the embeddings of men and women, have the difference between them, then you have the embeddings for king and queen. And if you do king minus men plus women, you're going to have almost the same number as the embeddings of queen. Queen is not 100% exact, but it's close by. So you can do some sort of mathematics with the words, with the semantics of the words, okay? Like day minus sun plus moon would be almost equal to the embeddings of night, something like this. You can do maths with words now if you do this kind of representations. Do you want to know how this works? We have some links for that later. But those would be the calculation of the embeddings. Then we would have the transformers block itself that do all of the calculation with the deep natural. Oh my God, just said that, I forgot. Deep neural network, yeah. Deep neural network. That took a while to come out. We would have these layers learned inside the deep neural network so that we can train that model to compute these parameters, the attention and the MLP Don't need to worry about that. That would route information around to compute those probabilities, those output probabilities. It's much easier if we just look at this image, okay? Not to fully understand the image, but to know how it comes. This transformer explainer is running GPT-2 here. That's a similar model to all of the other GPTs that came after this. That shows how can I process any kind of example here. So like, I can do the example of who discovered Brazil. Discovered Brazil was, and then I can generate. This is going to calculate the embeddings of who discovered the Brazil. I guess you don't have the word for Brazil there entirely. Maybe it was Trinity data set without that. And all of those would have a calculated embedding and the positional encoding to know where this comes in the phrase. Okay, there's the whole explanation for that here if you want to look at that. I would calculate the relationship of each of those words to each other. For example, discovered, how discovered is related to all of these other words. So we would have a carry and a value for all of these questions. For example, imagine folders. I have dog, I have pizza, and I have hot dog. I would know to put dog in the folder of animals and pizza and hot dogs in the folder of food because I learned to do this math with words. So then when we are searching for the attention of one word to the other, we would know how to look inside those folders from the names, from the little labels that they have for me to get the value. When I have the value there, I would do another block. This would be stacked on top of each other, like 12 of those in the GPT small. Then I would do the calculation of it, of what would be the most probable outputs. And we don't have Pedro here. Who discovered Brazil was like, was a, was the, was aqui, was in, was not. That are the probabilities that I have.
Probably these numbers are coming from a database, like the whole universe, internet, something like that.
Yeah, it's actually not a database search itself. It is the computation of the embeddings of all of these words plus the deep neural network. Here are some crazy activation functions, some maths that you're going to multiply this and that, and depending if it's higher than zero, is lower than zero, multiplied by that weight, and now you're going to do an activation. It's actually calculation. We somehow discovered a way to do math with words with this, which is very imprecise, as you can see here. Right. A healthy person should eat rocks every doing the calculation day, every morning, almost every night. So is this intelligent? No, this is just computing the most probable token. See, this is the third layer under the hood now. Now you know why it cannot count a strawberry, right? It's not thinking. It looks like it's thinking, but unfortunately it's not. Unfortunately, depending on how you see it, can be a good thing or not. So I have some exercises to introduce the subject here. The transformer explainer, the BERT for search, how it enhances the capability of searching. For example, when you want to ask some information, Brazil travelers to USA need a visa. So before applying these kind of transformers, it would show the first recommendation as the USA citizens willing to travel to Brazil. Why? Because this is the most probable outcome and all. And then after you apply these transformers, you now know that the person asking is a Brazilian or is in Brazil trying to travel to USA. And then it would give this correct output. Yes, it's needed. We need a visa to enter here not to be considered an alien, and now we got to do all of the paperwork. So this is the capability of transformers. We can understand. This is not GPTs, this is BERT, but it can enable that. And can go way beyond than just text. For example, it can be used for protein folding, for finding new compounds, some drugs or remedies or vitamins and all, can now be computed using this AlphaFold and AlphaFold V2 with much more precision just because of the use of transformers, just by the use of these models. Okay. I do have some suggestions if you want to experiment with transformers, running in your own devices or with this Google Colab. The Google Colab is a browser-based application that you can run models inside the cloud of Google without paying. There is a paid version, but you can run them without paying. And we can have some example notebooks like this that I have prepared. Actually, that someone else prepared, and I just put the reference here. That is a Python code, step by step, that you don't need to install anything on your machine. So it abstracts all of the work for you. So for example, I'm going to click on those boxes only to run this, and I'm going to inherit a model for doing sentiment analysis on things that I put here in this notebook. The link is here in the README with these practical exercises. Okay, I'm going to guide you through, but you're not going to have time to complete them within the lesson today. You might do that as a homework, and I'm going to show what to do if you have questions. So now that I installed this with this click, I can just run this pipeline. This is going to use transformers from Hugging Face, that company that I showed for you. And we are going to calculate this pipeline of sentiment analysis with these two data points. This is one of the exercises I'm going to explain today. Hello, Anna. Please feel free to join us. Okay. And this is going to use a BERT, one of the models that is available inside the transformers, inside the Hugging Face hub, to calculate the sentiment analysis on this data. So for example, I Love You had a positive score of 9999, and I Hate You had a negative score of 0.9999. Okay, it's good. So for example, I can say I love pizza, or my pizza is cold. I can do the analysis of those two things, and the first one was positive with a good score, and the second one was negative. Yes, cold pizza is not that good as warm pizza, right? Unless it's in the morning and you're really hungry, then anything goes. So I do have those exercises set up for you here. And some of you were having problems running the OpenAI APIs, right, in the Grok, right? You were having problems. Anyone else? Problems? I have these suggestions of some tools that you can run, that you can install on your own device, and you can load models with these. So GPT-4o, Olama, and LM Studio. This one got very famous because it was demonstrated by Apple. So these are very famous that you can install on your own device for doing the inference locally. So you don't need to pass your data for OpenAI or Grok or whatever. Okay. The problem is that it requires a quite powerful device, a GPU, and all for it to run properly. So it might need some tweaking for it to work properly on your system. Okay. I'm going to leave most of that as a homework for tomorrow. If you want to get those to run, you might need to download models from the Hugging Face. I have some indications here on how to do that. And as an exercise for tomorrow, we should create an account at this hub of Hugging Face, navigate to that model hub, and then find a text generation model for you to run in your own device. Okay, if you want to do that offline, if you want to do that private, without the usage of those data centers, even using your CPU for doing these inferences, it can work, okay? And for this bootcamp, you are going to build one project if you want. Okay, now's the interesting part. You can join as a group, at least 2 people. Let's try and cap it at 5 so that we have at least 8 projects active. But probably we want to have more than 10. And you're going to ideate something together. What do you want to build with AI in this school? What do you want to enable AI to do with Web3? What do you want to do in Web3 with the things that we are learning in AI? Right now we have a lot of possibilities. What I'm going to ask you is that you go here for this repository that you, if you don't have access to it yet, here's the QR code. Let's chance to get it. I'm kidding, you can ask it for it anytime. And we have this discussion tab with the projects. I just created that tab right now. If you go for the repository, you're going to see all of those tabs. Issues is a very important one. From today to tomorrow, you might want to try some of the things at home. You might have some questions and all. You can create issues in this repository, and I can answer them here, or your colleagues here can answer to ask about any question or any problem with the content that you have in the bootcamp. If you want to ask more information, do feedback, or present yourself and all, we have these discussions coming here. Announcements, Q&A, ideas, and all of that you can use freely. It's open. You can literally fork it and start doing your own bootcamps. The value is in the things that we build. And I ask you to create your submission for your project here inside this category. Okay? What are you going to do from today to tomorrow? You are going to come up with a project name. You can do 1, 2, 3 if you want. Okay, I have these indications. You may create several projects with different ideas too to help brainstorming with your group. Okay, so come up with at least 1 or more projects with the project name, a short description, and put the username of your teams there. The name, the email, the GitHub username there in the description. You're going to open it here, new discussion, and you're going to put it out here in the body. Okay, the link is here in the README, in this project discussion category. Okay, you're going to put this short description, and I want you to do this exercise of doing a small roadmap. What would be the actual step-by-step that you need to take, creating the front end, building a small backend, doing some email automation, or doing some Twitter integration, whatever, for doing this idea that you have, an automated AI agent, e-commerce platform, and whatever. And by the end of this bootcamp, you should have this demo working, or you should have at least a landing page or something of this project. Because if you attend all the days, or if you stick by all the days building together, and you come here on Friday, you're going to be able to demo this project for all of the participants, all the VIP, VCs, job hunters, and friends, and all that are going to be participating. So this is not going to be the end of the bootcamp, but it's going to be the beginning of the after bootcamp. It's going to be where the actual building starts. Okay, so it's not just about listening. It's about doing and starting something very cool, and I hope to be involved in that. Let's have a quick talk from Elena that is going to present the Supermoon Ventures or Supermoon Camp today, Elena. Give you the mic. And it's going to give a taste of what's coming from this book.
I can do something.
It's for the recording.
Can everyone go for it?
If you want. I should go. It's okay.
So, hi everyone. How many of you are already having a project you are working on? Please raise your hand. How many of you are thinking of an idea or want to have an idea to build a project? Okay, so
Nice.
Nothing but here. So my name is Elena Obenkova. I'm a founder of Supermoon. We built a pretty curated community in Web3 that also has a lot of AI builders in our ecosystem. Currently, we have more than 22,000 founders, builders, and investors. We help projects to raise over 20 million over this year with a few of our curated events. So we started originally as a hobby because we wanted to help founders to get connected with not only capital, not only investors, but also strategic partners and other network members that can support them. Previously, I worked over 6 years in venture capital. My background also includes advising United Nations on how to use blockchain and emerging technologies for financial inclusion. I also built an international consulting company with over 50 employees that had clients from 15 different locations. Also had an opportunity to live in 9 countries because of consulting, and also because I was naturally curious about different markets. And that led me to Supermoon, because the passion was always work with startups, with founders, help them to grow their businesses, remove any challenges. And since our community took off, I switched full time to Supermoon. And last year, we had to start moving in the next direction because our community was growing. So we scaled our own events, we started organizing startup days, helping projects to present in front of investors. And this year, our investor community said, guys, why don't we support you too? Because we also want to invest and we want to participate in projects that are coming from your system. So that led us to Supermoon Ventures. And for 2025, I'm really excited of our launch our first official founders program here in New York City with a special track dedicated to AI. So it's going to be intersection of Web3, AI, and other emerging technologies. It's going to be a 2 months program for founders that are at a very early stage. So it can be actually idea stage, MVP. We can also onboard founders that already have some traction and looking to scale and get access to our network. So it's actually going to be changing rebranding. So it's actually going to be like a founder's residence. It's not going to be under ECF.
Oh, nice.
So yeah, there's just like a last minute.
So you're going to have 2 of those?
So we're going to have one program. So it's going to be like a slight changing or like in the direction here. But it's going to be it's going to be a founder's residence together with Ethereum ecosystem. We're also going to have our participants from major L2s in the crypto space and dedicated AI vertical where we're going to focus on AI agents and other AI applications. So everyone is more than welcome to apply. You can visit supermooncamp.com for more information. We already released our application form. There are going to be some updates happening early next week. So then we'll have like up-to-date materials on the program. But it's 2 months program. Mentorship, there are going to be workshops, there are going to be social events, because we also want to make sure founders not only grinding, but also have an opportunity to network and connect with other ecosystem participants. And of course, at the end of the program, there's going to be a startup day. So all their participants will be able to present their projects in front of investors from our network. And of course, Supermoon Ventures is always looking for more founders, and we will be there to assist you throughout the entire program. So feel free to apply, and really looking forward to see you guys at more of our events here in New York City.
Wonderful.
And thank you, Mateus, so
Thank you so much for coming. Any suggestion for these people learning decentralized AI, like decentralized AI agents or decentralized machine learning? Anything that you would pick on the top of your mind as cool topics for us to explore?
I think like the main challenge that I see right now in the market from projects that are pitching to us is that a lot of people are getting stuck in the loop of just reusing like the hype technologies, but not really realizing what is the purpose of them using this technology. So I would always recommend to look at the market first, identify problems that exist in the real world, scalable market, especially if it's not like a passion project, if it's something that you want to grow and scale, you always want to look at the market numbers, identify this problem, and use technology as technology. I think AI is a definitely interesting vertical. We want to see AI expanding pretty much any vertical in existing business, and I really see a lot more corporate players stepping in the space and asking about AI agents. We're also working on one of AI agents for ourselves. So I think it's a definitely interesting market, and looking forward to sharing more during our program also.
Nice. Excited for more.
Okay.
Thanks, Elena. You're going to build a new link then for the residency program.
Yeah, we can share a new link, and yeah, we will be able to share with everybody.
Application are applied for this week.
Applications already live. I just need to get that for up to date thing.
Okay.
This application itself, because we will be changing like another website.
Good, thanks a
So
lot.
there will be Oh yeah.
Is it online or on site and online?
It's on site.
On site.
It's probably
How many weeks is that?
It's 2 months. Yeah, so like roughly 8 weeks.
See, full time, right?
It's gonna be full time. You don't have to be there full time. Because there will be like to build up agenda specifically for this program. Every week we will estimate at least 2 or 3 days that you will need to be on site. Some weeks it might be a little bit more. Plus, for select projects, there also going to be an opportunity to pitch at East Denver, which is one of the largest Web3 conferences.
Wonderful. Who's going to eat Denver? 1, 2. Okay, let's convince some people.
More people at the end of the bootcamp.
We do a bus. We do a bus from here to there.
From New York to Denver.
And we learn the way.
It's enough time. It's enough time to learn.
Yeah.
And
Thank you.
Oh, that's wonderful. So we have some good material here. I'm counting with all of you to be the greatest project. I want Elena to say that, hey, the best projects in the residency program came from your bootcamp. That's going to be a huge milestone for us. Counting on us, but also counting on you, but also count on us for that. And it all starts with this. So this is the moment that we are right now. We can take those last 20 minutes to do that. Make groups of at least 2 people. Less than that, 1.9999 or less. It's not considered as a group, as far as I know, if that's possible. So make a group, go there, chat with each other. Thank you. Maybe with pizza, maybe with some drinks, and get together to do this project discussion about your project right now. Okay, we have 20 minutes for that. You shoot your ideas. Hey, Matheus, what do you think about another AI crypto bot prediction thing? Oh, that's a good idea. Then we can chat about this now. And at the end of today's lesson, we're going to have those 10 projects submitted here. And we're going to keep doing that until Friday. So we pitch and we raise millions of dollars, right? Yeah, I'm kidding. You might raise it, but you might get jobs, you might start your projects. Everyone has your own goals for that, right? So let's do it right now. Let's get together and do some regulation. Yeah. Even last day, while I was explaining this, Carol, maybe I didn't stress that enough. At the end of the bootcamp, we are going to have a demo day at the last hour of the Friday. Today? Today we have those networking. I don't know how many of your friends have chatted here, but the idea of the project submission can be for you to use the project submission to brainstorm with your team, or even to find other teammates. Because after you submit with your friends, you can be scrolling through all of the other submissions and find something that you want to work on. Okay? Or you might find another person that submits something very similar to you, and then you merge. Okay? So this is a place where you're going to vomit a lot of ideas. Don't put too much of work on that. Just to spit out the ideas, do some sort of guidelines there, and you can use that for team formation, okay? Do not necessarily form teams based on skills, okay? Ideally, if I do a good job, everyone's going to have the skills to build it. So try and pick by affinity, by idea, by what you are excited to build on, okay? And I'll be here helping you to do this.